यहाँ पर देख लो, find the torque about an origin when the force 3J is acting on the particle whose position vector is 2K बोल के पूछा. Okay, so you should know that torque का फॉर्मूला क्या है, R क्रॉस F. Okay, तो पोजीशन वेक्टर क्या दिया, 2K दिया. इसका मतलब R bar. What is R bar here? R bar is nothing but 2K bar. 2K crown unit vector. And force क्या दिया यहाँ पर, force is nothing but F bar, which is nothing but 3J crown. So therefore torque is nothing but, so 2K crown cross 3J crown. Okay, तो ये हो गया आपका क्रॉस प्रोडक्ट. ठीक है, तो यहां पर देखो क्या बोल के लिखेंगे, 2 3 जा 6. ठीक है, आप लिखेंगे 2 3 जा 6 और यहां पर क्या बच रहा, K क्रॉस J बोल के बच रहा. यूनिट वेक्टर क्या है, K क्रॉस J. सो K क्रॉस J इज नथिंग बट माइनस I. क्यों, ऐसा क्यों, देखो I J और K एक ऑर्डर में लेना पड़ता हमको. ओके, ये I क्रॉस J इज इक्वल टू प्लस K, J क्रॉस K इज इक्वल टू प्लस I, और I क्रॉस J इज नथिंग बट प्लस K, और K क्रॉस I इज नथिंग बट प्लस J. अगर इसका रिवर्स हुआ तो माइनस लेना पड़ता, जैसे कि K क्रॉस J इज नथिंग बट माइनस 1 और J क्रॉस I इज नथिंग बट माइनस K. उसी तरह I क्रॉस K इज नथिंग बट माइनस J. ओके, अगर ऑर्डर में लिए तो प्लस लेना पड़ता और ऑर्डर ऑपोजिट लिए तो माइनस लेना. वी आर गोइंग टू कंसीडर वन रॉड हियर. ओके, एंड दिस रॉड इज कंसीडर्ड एंड वी हैव टू कंसीडर व्हाट, 2 particles of 5 kg and 10 kg. एक 5 kg का एक particle ले रहे हैं हम, one particle of 5 kg and another particle is at this place. Now let us see what is going to happen. This is, let us imagine 5 kg and this is taken as 10 kg here. Okay. क्या है लेंथ ऑफ द रॉड, क्या है यहाँ पर, D. लेंथ ऑफ द रॉड इज टेकन एज 1 मीटर. ठीक है, 1 मीटर विद a negligible mass. The center of mass of the, so balancing point is somewhere, let us imagine at this place. अगर balancing point उधर हुआ तो हमको करना क्या है अभी, what are you going to, तो ये क्या करेंगे, D minus x बोल के ले लेंगे. Okay, total distance is D. This distance is x, means remaining distance is D minus x. Okay, then okay. So what are we going to do? So m1 into this distance is equal to m2 into this distance. Okay, okay. तो यहाँ पर 1 meter is nothing but 100 centimeters because answer centimeters में है. The answer is in centimeters. So what is considered 100 centimeters. So mass into this distance, this mass into this distance will be always same. That is called as the concept of principle of moments. तो यहाँ पर m1 क्या है, x, m1 क्या है 5 है और x तो x ही है यहाँ पर, m2 क्या है यहाँ पर 10 kg. ओके, और डिस्टेंस क्या है यहाँ पर 100 सेंटीमीटर्स. सो 100 माइनस x बोल के डाल देंगे. x इज इक्वल टू 1000 माइनस 10x, तो देयरफॉर 15x, ये 10x लेफ्ट साइड आया तो 15x which is equal to 1000. 15x is equal to 1000, तो x is equal to, okay, so 1000 divided by 15 you'll be getting how much, some 66.6 बचा था. So your answer is going to be 67 centimeters. Okay, so this is in centimeters. So like this you have to do. Okay, like this you have to do the problem. Okay, now next you just see here, a rope is wound on a hollow cylinder of mass 3 kg of radius 4 centimeters. Okay, hollow cylinder बोल के बोल रहा ना. So what do you mean by hollow cylinder? Hollow cylinder is nothing but it should be empty in the middle, nothing is there, just like a drum. Drum is a hollow cylinder, best example for hollow cylinder. Okay, next क्या, a rope is wound around a hollow cylinder of mass 3 kg. So mass of the cylinder is 3 kg. A rope is wound on a hollow cylinder and radius is given here. What is the radius? So radius is given as 40 centimeters. What is the angular acceleration of a cylinder if a rope is pulled? Okay, so here there is a rope which is pulled by a force, and what is the force applied? 30 newtons is the force applied. Okay, okay, so what is the formula actually? Torque is equal to I alpha, just like force is equal to mass into acceleration in the case of a linear bodies. Okay, just like here torque is equal to I alpha. What are you going to consider here now? Torque, another formula for torque is equal to Rf. Okay, there are two formulas for torque here. Now you can make these two formulas equal. I alpha is equal to Rf, so alpha is equal to Rf by I. So R into F by I. I is nothing but, and there are two knife edges A and B here and here. There are two normals here and the distance where two normals is taken as D. That means let us take this is x, that means remaining distance is how much, D minus x. Okay, so two concepts you have to apply here. One is these two forces are acting upwards, weight of the rod is acting downwards. Center of mass of a rod is here where weight is acting completely downwards. So what are we going to do now here? N1 plus N2 is equal to W. So N2 is equal to W minus N1. This is equation number 1. Keep it like that only. Okay, next thing is, okay, this normal reaction into this distance and this normal reaction into this distance will be same. So we can write N1 into X is equal to N2 into D minus X. Okay, and N1 is writing like that. So N2 you have to convert into W minus N1. So this can be taken as N2, which can be taken as W minus N1 into D minus X. Okay. So therefore N1 into X, so W into D minus W into X and minus N1 into D plus N into X. Okay. So N1 into X. You can just see here what are the things getting cancelled here. N1X gets cancelled. Then what is left? He is asking us to find out the normal reaction. Means you have to find out N1. Normal reaction at A he is asking. So N1 you have to find out. Okay. So you'll take N1 to left side. N1D is equal to Q. If you common out here, you will be getting D minus X. Therefore, N1 is equal to W into D minus X divided by D. So this is the fourth option as an answer. Now, the automobile is moving on the road with a speed of 54 kilometers per hour. The radius of the wheel is given. So automobile's wheel we have to consider here. So let us consider one wheel of an automobile here. So what is the radius of a wheel? Okay, automobile wheel is having a speed. What is the speed? Is nothing but 54 kilometers per hour. So 5 by 8, 18 threes. So velocity is going to be 15 meters per second. So we got the velocity and we got the radius of the wheel as how much? 0.45 meters. Okay. So radius of the wheel is there. So this is taken as 15 meters per second. Okay. So velocity is nothing but 15 meters per second you are getting. And he is asking us to find out average torque acting on the wheel to apply the brakes. So if you apply the brakes here, torque is going to act on the wheel here in the opposite direction. So when the torque is going to act to stop the wheel, what is the formula? Torque tau is equal to I into alpha. Okay, alpha is equal to W2 minus W1 by T. This is just like acceleration is equal to V2 minus V1 by T. So alpha is equal to W2 minus W1 by T here. Okay, so I into alpha W2 minus W1 by T. And W2 it is going to be rest, no? So final velocity is 0, initial angular velocity is nothing but V by R. So W1 is equal to V by R, which is nothing but 15 by 0.45. Okay, so 1500 divided by 45. So W1 is equal to 100 by 3, you are getting radians per second. What is I here? Moment of inertia is given as 3. So 3 into W2 is 0 and W1 is 100 by 3 all divided by time is given how much? 15 seconds. Okay. So if you solve this one, you will be getting like this 6.66 and continuously you'll get. So we can write 6. Now you can consider there is a rod here. A rod is hanging at one end. Okay, and one end you are holding this rod. After some time you are leaving the rod. That means this rod which is holded like this, it will move like this. It becomes vertical. The horizontal rod which is tied to one rope, when it is holded like this and left after some time, it comes and becomes straight. So he's asking us to find out what is the initial angular velocity at this place. So how are you going to find out the initial angular velocity? So this is a rod and at the end, what is the moment of inertia of a rod at the end? Already I told you that if you consider the rod, moment of inertia with respect to center of gravity is nothing but ml square by 12. With respect to end means what you have to do? With respect to end means I is equal to Ig plus mx square. Here x is nothing but L by 2, half of the rod. So therefore I is equal to Ig is nothing but ml square by 12 plus mx square. What is x here? L square by 4. So if you simplify, you will be getting ml square by 3. So moment of inertia are getting. Okay. So let us see what is going to happen now. So how many torques are acting? There are two torques. Torque is equal to I into alpha and another torque formula is nothing but R cross R into F. This is 1 and this is 2. Wherever you go, these two formulas you have to make them equal here. Then what are we going to get now here? He's asking us to find out initial acceleration. So I alpha is equal to R means radius. So what is the radius? It will become L by 2. Okay, radius of the rod when it rotates in the form of a circle is going to be I alpha is equal to R cross F. So radius is taken as R into F now. So force is acting at this place, mg. Okay, mg is acting exactly in the middle and the distance from mg is taken as, see, center of gravity is acting at the middle, so L by 2 you have to take. So R is nothing but how much? R cross F. So F is nothing but force due to gravity. So R is nothing but this radius, that is L by 2, and F is nothing but mg for a rod. Okay, mass of the rod is given here and g is taken as that one. So what is the moment of inertia here? Moment of inertia, I told you it is going to be this value. So ml square by 3 into alpha is equal to L by 2 into mg. So we have to cancel the things here. So what are things you are getting cancelled here? L square gets cancelled here. He's asking us to find out alpha, no? So alpha is equal to 3g by 2l. This L is left, so it comes denominator, 3g by 2l is your option. Okay. So let us go for the next problem here. So what is the next problem here? At this point O, ABC is an equilateral triangle at O. As its center F1, F2, F3 is present here as O. Center is the O. AB, AC and BC are acting here. If the total torque about O is going to be 0, and total torque is acting at this place is going to be 0, then the magnitude of F3 is asking. Okay, so total torque net is going to be torque 1 plus torque 2 plus torque 3 here. So torque net, so let us imagine this distance from here to here is R, this distance is also R, this distance is also, so RF plus again tau 1 here, RF, tau 2 means here also RF1, this is F2. Okay, but here torque is acting in the opposite direction here. So these two are acting like this, is acting in the opposite direction into F3. So this direction is opposite, that's why I write like this. And the net torque is going to be 0 means total torque is going to be 0. So R you can common out and cancel. What is left? QT, which is nothing but 2 minus 60 square, that's it. The torque on the wheel becomes how much? So he's asking us to find out the torque here, isn't it? So torque you have to find out means, first you have to find out what is the angular acceleration. Torque acting on the wheel becomes 0. Okay. So for that what you have to do now? First of all, what is this? This is called as angular position means, let us take this as theta is equal to 2t cube minus 6t square. Just like a displacement is given and you want to find out the velocity means you have to take ds by dt. You have to find out acceleration means you have to take again dv by dt. Here this is called as angular displacement. So angular velocity, if you want to find out, you have to differentiate this value d theta by dt. So 3 2s are 6 t square. Okay. So angular acceleration is asking us to find out. So again you have to differentiate this once again, d omega by dt. So 6 2s are 12t minus 12 will be there, dt by dt is going to become 1. So this is called as alpha. So he's telling that the resultant torque, the torque acting on the wheel is going to be 0. Tau is equal to I alpha is equal to 0. So I and alpha value is given 12t minus 12 is equal to 0. That means 12t minus 12 is equal to 0. I also becomes 0. So 12t is equal to 12. So t is nothing but 12 by 12, which is nothing but 1 second. Okay. So 1 second is going to be your answer, D option. Now let us go for the next problem. So the uniform rod of length L and mass m, okay, rotate in a vertical plane about A. The rod initially is in the horizontal position, is released. The initial angular acceleration of the rod is how much? So same problem as the previous one. Here it is holded, it is released from here. If it is released, it will come downwards like this. If it is released, it comes downwards like this. And he's asking us to find out what is the initial angular acceleration, same as the previous case. So here at this place, mg is acting force and this distance is taken as L by 2. Okay, so torque tau is equal to I into alpha and tau is equal to R cross F. These two formulas will be regularly using, we are using these formulas regularly. So that is I into alpha is equal to R cross F. Rod at the edge. As usual in the previous problem, we have taken ml square by 3. When the moment of inertia of a rod from the edge is taken as ml square by 3 and this is alpha, R is how much? Radius is going to be L by 2 here and force acting is taken as mg. Okay. So m gets cancelled, L square L gets cancelled. Alpha is equal to how much? This 3 goes to that side, it is going to become 3g. One more L is left, comes to denominator. 3g by 2L is going to be our answer. Okay.